this afternoon is Jack with the Chisel update. Take it away, Jack. Thank you.
Thank you very much. Hey. All right, so hi. As Jules stated, my name is Jack Koenig, and I'm one of the maintainers of Chisel. Hopefully, many of you have heard of Chisel. I bet most of you have. Hopefully, at least some of you have used it. This is mostly an update for Chisel users, but if you're not a user, hopefully some of the stuff you see here will make you want to become one. We'll see. All right, so just a brief outline of what I'm going to talk about. So I hope most of you have heard of Chisel, but I also hope there are some who haven't. So I'll give a bit of background about what it is, and then I'll talk about what's new. I'll talk about what we're working on. Not a whole lot there, but hopefully it's interesting. OK, so first of all, what is Chisel? So Chisel is a backronym for constructing hardware in a Scala embedded language. But what is it really? It is a domain-specific language where the domain is digital design. So Verilog is a domain-specific language where the domain is digital design. It's just this is not a general-purpose language. You can't use this to send a curl request or whatever. This is very much a digital design language. It is neither high-level synthesis nor behavioral synthesis. So I think there's a lot of really interesting work going on in new hardware description languages that are true languages with semantics that lowered certain things. This is not really that. This is basic constructs in Scala that you can use to write a program to construct your hardware. So you write a Scala program, and why is Chisel embedded in Scala? Scala is a modern general-purpose programming language that has a lot of things that we think are really good for software engineering. Like parameterized types, object-oriented programming, functional programming, and static typing. Now, I said that that's good for software engineering, but we're talking about hardware here. And I think one of our real goals is that there really shouldn't be that big of a difference. When you should be adopting software engineering practices when you design your hardware. And there are modern language features that help you do that. The purpose of Chisel is to write reusable hardware generators, also known as libraries. I talked about software engineering. What is great about software usually? You can use a library to do something. It's already been written. You can just use it. And so the goal of Chisel is to help you write libraries for hardware. And as I said, Chisel is not any type of synthesis. You can write Chisel that looks a lot like Verilog. So here we have a moving sum filter, I guess. It has an input, it has an output. It's got 2 registers, and we are just summing across 3 cycles. Right? This looks a lot like Verilog. You could write basically this with Verilog. Yes, OK, in Verilog you might have an always block. Oh, the clock here is kind of automatic because by default modules have a clock, because most things you write have a clock. But at the end of the day, you made registers and you added them together. It's not that crazy. But the point of Chisel is, OK, that's a 3-point moving sum, but what if you have more than 3 points? What about weighted averages? What you really want is a generic filter. So in Chisel, it is very easy to parameterize things. So in this case, we have a parameterized filter that, don't worry about the code too much, but we have, it's parameterized by a bit width, and it's parameterized by the number and the values of the coefficients that you're going to use in your filter. And so the number of coefficients you have is the number of cycles across which you will be filtering, or you will be using to calculate a value. And then the coefficients are what you're multiplying down here on the products, which you're multiplying each stage of this filter across. And then we add them all together at the end. Right? And so the cool thing about this is that this is a bit more code than the previous example, but it's more generic, and it implements a lot of different things with no cost in the hardware. There's no overhead. This is essentially metaprogramming that allows very powerful parameterization. And so we can have, using this more general filter, we get that earlier filter for free, but we also get different kinds of filters. You could have what is essentially just a 1-cycle delay that I'm calling a delay filter. You could have a triangle impulse response filter as well, all with the same code. OK, so that's the basics. Now you're all Chisel experts and users, so now the update is for all of you. So what's new? The biggest new thing is that we released Chisel 7 RC1 a week ago. It's in pretty good shape. It's already being used in production. But this is a big release. We haven't had a major release in over a year. So we want people to use it, give feedback. I promise this every single time, and it hasn't happened yet, but we are planning to do faster major versions, like maybe every month or 2 instead of, I don't know, once a year or so. We'll see if I can keep that promise. But I'm going to follow up with some more recent highlights. But one thing I just want to note is I'm not really going to talk about probes or properties. Probes are what we call cross-module references, and properties are essentially a way to represent metadata. I talked about those last year, so go back and see that talk. I just want to mention that those APIs have matured a lot in the last year. All right, so moving on to kind of some of the new things. So Chisel Sim is the kind of built-in simulation library, if you will, to help you run like unit tests and simulations. It kind of existed a year ago, but it wasn't usable at all. And like practically speaking, it required so much user customization, it was really hard to set up. Nowadays, it has a lot more built in. Essentially what had happened is that it was like too generic. It was basically like all the tools you need to build your own simulation infrastructure, but no one wants to do that. And we had a lot of stuff internally at Sci5 where we had used it, but what we basically did is we took pretty much all of that, cleaned it up, and upstreamed it. So now it has things like directory control integration with Scala tests, which is a common testing framework in Scala, which is kind of what's shown in this code example. You can like write, describe what you're going to test and whatever, and put a little simulation there. It has command line arguments. It has reusable stimulus. We also have file check integration. So file check is this interesting, it's kind of like a super string checking library that's used by LLVM for testing. This is not something that like most hardware users should use, but we have actually found it's super useful for testing libraries. When I'm writing a Chisel library and I know what the Verilog I want to look like, it makes it really nice for testing that. So we also now, that is part built into Chisel Sim as well. Another thing that has probably been requested since Chisel was first started like over 10 years ago, but now finally exists, is so we now support format strings in printing, something that shockingly we just never really prioritized. So that includes with specifiers and things like hierarchical module names and simulation time. And also really importantly, rather than just the default logging, you can log to files, and those file names themselves are format strings. So you can, at runtime in your Verilog, or in the Verilog simulation, be deciding what file you want to write to. Now, it's, as anyone here who's used Verilog knows, that %d almost never does what you want it to do, because it always pads it with spaces. We've tried to change the default to start emitting %0d, but that broke a bunch of stuff, so we're stuck with the same default as Verilog. But if you do have a format string configured file name, make sure to put a 0 there, otherwise you're going to have some really weird file names. And also make sure not to use a register that you don't initialize, or you're going to be writing to random files. Another just kind of a nice quality of life thing is module prefixing. So this actually previously existed as kind of a semi-private API, but it was something you could use. But now we've taken it, made it a first-class API, and and the prefixes are also nested. So this is really the main use case of this. Is it kind of works around Verilog's lack of namespaces for modules. So if you are going to be using the same generator to generate like a high performance and a low performance version of something, and then you want to put them together in Verilog, it is important to make sure that the names don't collide. This is a very subtle point that I don't have time to get into today, but this provides some user control over how things may be multiply instantiated. So I'm trying to think of the best way to describe this. Like basically, the Fertile compiler is going to try to minimize the number of modules you have. It will deduplicate things, but that's not always sometimes what you want. Sometimes you're like, yes, I'm generating this big thing, but I want to be able to take pieces of it, and they need to work on their own. And so this also allows you to, if you make something a prefix domain, then it will be self-contained. It will not use things from across the domain, and therefore you know that Verilog can be used on its own. So these are like little quality of life things that are meaningless to you if you haven't used Chisel much, and are the kind of thing if you have, you're like, thank goodness, finally. All right, so layers was a new feature I did talk about a year ago, but it's undergone much more, or many more changes than some of the other things, so I wanted to highlight some of that. So what a layer is it's sort of Chisel's way of grouping verification logic. So typically you would do this in System Verilog by making a little module, and then you would use bind to bind it into the module, right? So this is kind of like that, but maybe a bit more general, because not only can it lower to binds, it can lower to if-defs. Unlike binds, which by System Verilog specification can't be nested, you cannot bind into something you are binding. You can have nested layers. And the Verilog ABI, how they lower, you can really enable them mixing and matching. I didn't show nested layers here. I only show one layer in this example. But you can have like A.B.C, and you can enable just A, or A and B, or A and B and C. And so it's really powerful. This is like really useful if you're like an IP company and you might want to ship some of your verification collateral to a customer, but not all of it, or you want to enable some of your verification collateral for some simulations, but not all. It provides a really nice structured way to deal with that. Now, some of the new things are, it not only can lower to binds, it can also lower to if-defs, if that's your preferred flavor, and you can have different layers lowering to different things. You can now force from outside of the layer. Previously, that was not allowed, so the verification logic under verification conditions can force signals. Verification engineers love to make a queue pretend to be full, stuff like that. And another thing that it does is it syncs logic from the outside. So Chisel generators are highly parameterized. There may be logic that you use under some parameterizations, but not others. And a lot of times, if that logic is like feeding assertions, but is not used by the design anymore, it would just be sitting there and you'd get lint errors, or your customers might get lint errors because they may not have the layer enabled. But now, if that logic doesn't affect the actual functioning of the circuit, it will get pulled into the layer, kind of like pulled into it, which is pretty cool. All right, and this is just an example showing how you might use that forcing out of a layer to model stuck at fault. And this is showing kind of the layer ABI that like only if you enable, so this is using an inline, which is the if-def lowering, and only if you enable or if you define this macro will that stuck at be enabled in your Verilog simulation. Okay, so now these are things that I couldn't justify giving their own slides, just a lightning round of other nice quality of life features. Literal preservation, which is kind of shown in this example here. There's a lot of operations in Chisel that used to not preserve the fact that something was a literal. It would create, like this doesn't matter that much. It wouldn't actually affect the real hardware you're building, but it affects how you write your generator because previously Chisel wouldn't know that X is a literal, and nowadays it will. So here I'm taking just a uint, putting it into nibbles, reversing them, taking one, and it will still preserve that that's a literal. A new feature is you can now mark things as read-only, which is really helpful if you're doing stuff connecting to it and then you're going to return it and you don't want your user to like overwrite what you did. You can essentially stop them from doing that. There have been some pretty big performance optimizations depending on what you're doing. Chisel uses between 25 and 50% less memory than it did a year ago. Another small quality of life improvement is shown here. These are smaller stack traces. So you are writing your own Scala code. You can have bugs that throw exceptions, and Chisel is a library, so Chisel will show up on your stack trace. And it's the thing about Scala and functional programming is you tend to write a lot of functions, so you tend to get really deep stack traces. And so there's a lot of noise from just Chisel on your stack trace, so we've done some work to reduce that noise, which you can see here, that reduction. And then another nice thing is for a tool that ships with Chisel is now statically linked, so it should work on older Linux distros. That's been a long request. All right, what's up next? And I have like 3 minutes, so I need to move fast. But I only have 3 slides. So a big one, and again, this is another subtle point, but when you're writing something like Chisel, what most people, your verification team or your customers care about, they don't care about your Chisel, they care about the Verilog you're giving them. And they want that to be what's verified. And a kind of subtle issue that you don't have in like typical software is like if you have, let's say you have equals, right? That's a function you might enable for it, or you might define for a type. And the way you're going to implement not equals as not of equals, right? And you test both of those, and then you're good, and then you ship a binary. But what's actually happening when you call not equals in your binary is it's getting inlined, right? It's going to inline the equals implementation in the binary. Well, the thing is, that kind of happens in Verilog, but now, like for the Verilog we generate, but now you have 2 different things, and they're like, well, I need you to verify both of those. And it's like, yeah, but this is just an optimized version of that. So it leads to a lot of problems that you just don't have in software. If you trust your compiler and nobody trusts your compiler in hardware, they trust but verify, right? So basically, we now have the ability to define unit tests that kind of go along with the design, and the same test you wrote can apply. Like if you write a unit test for a queue, that unit test can be carried along with it and can be run on all queues in the design on the actual Verilog to ensure you can get coverage. And there's a picture. Chisel is a function from parameter system Verilog, and now with tests as well. Another thing that I'm really excited about is formal contracts. So these are similar to the inline unit test, but with a lot more math. So formal verification is generally very computationally challenging. And so there's new APIs for helping you. This is something you could already do, but it's kind of inconvenient, and we're trying to make it more convenient. You can, if you write a formal contract for your module, right? So here I have a parent and a child module, and each one has a formal contract. Typically, if you were trying to prove these parent properties, these assertions, you would run it on the entire thing, and that's really slow. But what these contracts allow you to do, you might have heard of like inverting your assumptions and assertions, is if you prove the child with its contract, you can kind of, this is my way of trying to show like you can invert that and use that as a model for the child and the parent, and therefore the child is no longer included in the proof for the parent. A much simpler form of it, those properties you already proved are included. And so this is a lot of work in order to make this really convenient to do, including the ability to run this on different formal engines like proprietary ones and open source ones as well. And then finally, this slide's from last year, still promising Scala 3. We're still working on it. It's it's a lot of work, but more importantly, it's low priority work. Like we're all more interested in features than we are in the version of Scala we're using. So it just tends to be a lower priority issue, but we are still working on it. And so that's all I have. If you're interested in getting involved, go to chiseling.org. You can now use Chisel with just installing one thing, so you should try it. Like just go to the webpage, click the big getting started button, and try it out. Thanks.
Hey. Nice one, Jack. Thank you. Questions? Any questions? It's good to see. Like I'm loving seeing Chisel continue to be developed and supported by folks in the industry, and still being open sourced, etc. So, yeah, great work.
Great.
Awesome.
Thanks.
There are some questions. Sorry. Did you have one? Or no? Sorry. Okay. Here we go.
Yeah, so Chisel Sim, does it use, is it simulating the Scala directly, or is it emitting, say, Verilog that's actually doing the verification code in Verilog?
Yeah, it runs Chisel to generate Verilog, and then Chisel Sim is sort of like wrapping up Verilator or VCS to run the simulation, and then communicating from Scala, because you can write test logic in Scala, sends that to the simulation.
Okay, so would that work for like a gate level simulation where you're simulating the synthesized Verilog?
It could, but it's not. It doesn't make that convenient. That's definitely theoretically possible, but not. I would not say that it has that path at the moment.
So for chips that you tape out at Sci-Fi, do you write separate Verilog tests for your gate level sims?
That's a fair question. So we mostly use, and most people use Chisel Sim basically for unit tests. You're fairly confident that this piece works, but it's not what you're going to use to sign off. And then actually that's like kind of a big piece of what the gap that this inline unit testing is trying to fill, because this works. You can write these style of tests, they work with Chisel Sim, but these also then are carried along with the design as it goes to Verilog, and it emits something that you can then run on that Verilog or potentially on the gate level netlist. And so that's kind of bridging that gap. One of the challenges, so Chisel Sim sort of does build tooly things, right? It invokes Verilator for you, it then runs your C compiler, and that's useful for making things really easy to do, but it's kind of bad if you want it to integrate into your other build flow that might involve a lot of other stuff. So the inline unit testing is more like, I'm not the build flow anymore, I'm just making it easier for you to write tests, but you still are going to have to be invoking VCS or Verilator yourself. It's kind of a subtle issue. It's one that kind of comes from using it more, but that's sort of, for sign-off, this is more the direction that we're going than Chisel Sim, if that makes sense.
Thank you. And also, I was wondering about the general adoption of Chisel that you see like outside of Sci-Fi. I know that in academia it's pretty popular, but I guess in more the industry.
It's a really hard question to answer because people just don't tell you when they're using stuff, and the best way to find out who's using your stuff is to break something and then see who complains. But we try not to do that. That's always that I can think of an accident.
Hidden time bomb in the
code. And it's like unfortunate because you'd think, oh, can you check like Maven Central downloads, see who's downloading it, but not really, because most companies like cache it immediately, so they will download it one time and then use it internally forever. Mm-hmm. So I don't know who's using it. I know people do, because sometimes I break things, but.
Thank you.
If you are using it, let me know.
Yeah, show of hands. Who here is using Chisel but hasn't told anyone about it? Yeah, I mean, the company I work for does, and we love it. Sorry? We tell everyone, yes, I'm on record as that, but I think there's plenty of people who are using it, right?
Let's start making people open a PR to add their name to a list before they're allowed to download it. That's a new license, Apache Plus.
I have a question, Jack. So could you just give us a minute on what's happening with Circuit? How's Circuit going?
Yeah, so Circuit is, the Fertile compiler is implemented using Circuit, which is kind of it's a generalization of LLVM. Sorry, MLIR is a generalization of LLVM used by Circuit to build hardware compilers. And it's a much bigger project than just Fertile, although Fertile is a big piece of it. It's very active. I don't participate in the day-to-day development, but if you go look at the repo, it is extremely active. There's Fertile, as I mentioned, is one big piece, but there's Calyx. There's all kinds of other compilers using it. It's really cool. And they are getting pretty good at Verilog ingestion, which is very exciting. So I think the hope is that a lot of the goodness that we get in Chisel, some of it we get just because we have a compiler. And they're hoping to be able to apply at least some of that to just Verilog as well, which will be nice, in addition to all the other languages using it.
Yeah, very cool.
Are you sabotaging that? Keep Chisel interesting?
Of course not. No, everyone thinks that it's fine to just write your own thing that emits Verilog. It's easy, whatever. It's like a lot more annoying than you ever think. You may know it's annoying, and it's more annoying than that. I promise. So, and it just never ends. You're always like, okay, I did it. It's perfect. I have a compiler. I never have to touch it. You will have to because there's so many tools. They all disagree on what Verilog they want. It's just like, trust me. Let someone else emit your Verilog for you.
Is the truth. All right. Well, time for one last question. Why not?
My favorite part of Circuit is that I don't have to do that anymore because I used to control the Verilog emission, and it was awful.
Yeah, I was going to ask about that. So you said that a lot of the companies, that Sci5 might sell to, they want the Verilog, right, at the end of the day. But they also want to be able to look at it sometimes. How, when Chisel emits Verilog, I don't know if this is on the Circuit side or Chisel side, but has the readability been improving? What if you're trying to trace what a particular circuit component corresponded to and stuff? Has that been improving?
Yeah, that was a pretty big step improvement when we went from the old Scala Fertile compiler to the Circuit compiler. It's pretty decent. I mean, it's still, you're running a generator. You can write generator things that will map weirdly, but for the most part, it does a pretty good job.
So that's a solved problem now.
Solved enough, I think.
Solved enough.
Yeah.
Thank you.
And just a quick question. There's no one selling Chisel IP today, right? Generally, Sci5 do not, as I understand it. You guys?
I'm not aware of anyone selling Chisel IP.
And is there anyone who's doing Chisel kind of contract work, consulting work, or guns for hire in the Chisel world?
Not that I'm aware of, but if you're doing it, you should, let people know on the Chisel users mailing list.
Yeah, cool. All right. We'll have to leave it there for today. Thanks, Jack. Great talk. Thanks for the update. Cheers.